Our next speaker is Liz Goergen from Nova Southeastern University.
All right, thanks Megan, thanks Tom. I'm here to talk to you about outplanting Acropora cervicornis and a potential different methodology on how we talk about the success of our restoration programs. Acropora restoration really has picked up in scale following 2006 listing under the U.S. Endangered Species Act as threatened. Young et al. In 2012 listed that over 60 groups throughout the Caribbean are working towards restoration of Acropora species alone. And Florida really is common in this restoration program. We have a big group of restoration nursery practitioners here, many of which are in the room. We span nurseries all the way from Broward County, just offshore this building here, down through the dry Tortugas, with many outplant sites in between those nursery locations, outplanting thousands, tens of thousands of corals a year. And our main objective for this group, and I think many restoration practitioners across the Caribbean, are to really facilitate ecosystem recovery by outplanting many genetically distinct colonies to many different reefs, in the hopes that we increase the likelihood of successful cross-fertilization and the potential for natural recovery, adding to the long-term ecological habitat improvements. And we're doing this through monitoring for success by, are these corals surviving in the place that we outplanted them? Are they growing? Are they healthy? And there are many people out right now looking at if these corals are actually spawning and reproducing. However, this coral is a pretty unique beast to work with. As many of you know, this coral has the ability to reproduce asexually and propagate sites through fragmentation. It can survive in many different forms, from the fragment loose rolling around on the substrate to an attached colony. These colonies grow together and form these masses, and these masses grow together to form these patches or thickets, tens of hundreds of meters in length, which causes a problem because it can also go frequently between these different stages. And this causes a problem also when it goes and skips these stages or back and forth through these stages pretty frequently, through storms, through disease events, through any other destructive events. It's a natural process that happens with this species. However, it causes a problem when we're trying to monitor this species because it's not always where you left it. So what we've been doing with this species, and which I think is common because it's what we do with other stony coral species, is we monitor individual colonies in what's called fate tracking. So we put this colony on the reef. This is a progression of images of the same colony over 3 years. And we monitor that particular coral in the place that it was outplanted next to the tag and look at things of whether it's surviving, whether it's growing, and the health conditions on that coral. And now there are a lot of pros to this type of data collection, is that the survival is based on where we outplanted that coral. So we know each individual, and it's really well suited for tracking the health of individuals over time. It's easy data collection technique. You can send out a bunch of people, have them find tags, and have them find the corals. And it's really good for determining if your attachment techniques are working for your outplanting program. However, if we have this case, like I mentioned before, this species is known to fragment and to become dislodged. This is a progression of another colony where in 2016, all of a sudden it's dislodged, is gone. So under our current methodologies of fate tracking individual colonies, we would call this a not surviving colony within our data set. Unknown what happened to that colony in 2016. However, is this correct for monitoring the success of a restoration program, especially with a species that's known to reproduce asexually? So there's also some cons to this type of data collection, which is also a pro, is that it's based on where we outplanted that colony, next to the tag that we put out, which misses these certain life history characteristics, such as this frequent fragmentation and colony dislodgement. It's really not suitable for long-term monitoring because of what I've said before. This species can fragment so frequently that it's really not suitable to say that our programs aren't successful by looking at that one spot. And so I would say that over 2 years, this isn't really a good methodology to be monitoring your outplants, maybe even 1 year, depending on your location. And this type of data doesn't really capture the restoration impacts that we're having at a site level, or what I'm calling site propagation. So we're missing what's actually going on around some of our outplants if we solely look at colony fate tracking data. So to give you an example of this, this is one of our outplant plots. We had 4 colonies outplanted about 2 meters apart. These colonies are about 3 years old. I apologize for the next image, but it's what we have to work with. It's a little different angle. There's a Siderastria sideri at the top of both images. It's a little orange on the right one. And I'll put X's over where our outplants were or had been outplanted. And what I hope you can see in that bottom right-hand corner is the only remaining colony, although the other colony is off the image. You can just trust me that it was not there. So what we would report here in our colony fate tracking is a 25% survival of this outplanting plot during this period. However, what I'm pointing out here in the blue circles are the addition of 9 additional colonies surrounding our outplants that were not there in 2015. And if we solely use this colony fate tracking, we're missing this impact that restoration has at even a small scale surrounding our outplants. So to try to better answer this question and to look into how we can monitor this, we utilize 10 of our different outplant sites across Broward County. For those of you who aren't from around here, we're about where it says Fort Lauderdale is where we're sitting right now. So our outplant sites are both north and south of where we're sitting. At various depths, we've outplanted between 69 and 150 colonies per site and use variable different attachment techniques. I'm going to go through just those that were outplanted in 2013, which has the blue dots on the bottom and the darker mid-color blue dots on the top. All these sites were set up the same. We outplanted 150 corals to each of those sites with 50 corals in what I call an outplant array. Those arrays, which are the white boxes, are separated by 20 meters. And then 7 meters surrounding each of those outplant arrays, we mapped every colony and fragment, estimated approximate location in that area. We looked at their size using size class bins. Were they attached? Were they loose? Were they dead? And we did this annually starting in 2013, so when these colonies were outplanted. And we did this across each outplant array, so we have 3 counts for each site. So what are we finding? So our site names are cores 1 through 4. Cores 1 and 2 are south of the port, or south of where we're sitting. Cores 3 and 4 are north. And what I'm going to show you is the total abundance. So I lumped all 3 of those counts together of just the living colonies, just for simplicity here. Living attached and loose colonies here. So this first bar represents the time that we outplanted. So the dark bar is showing the actual number of outplants, so that's 150 colonies. And then beyond that is the small amount of wild colonies already in existence at that site. So core 4 had 0, although it might look there might be 1, but there's actually 0 wild colonies at core 4, and up to core 1 had 35 wild colonies. And I'm going to walk through each year that we collected data. So this is 1 year post outplanting, and we see nearly doubling at cores 1 and 2 in the colony abundance, and cores 3 and 4 are a little slow to fragment and increase in abundance. This is year 2. We still see a spike in years 1 and 2, where we're seeing cores 3 and 4 are now kind of picking up pace and becoming more abundant in their colonies. Unfortunately, we weren't able to get out in 2016 to collect this data, but we were able to get out again this year, earlier this year. All these collections were done in April of each year. And we're seeing a nice increase at cores 3 and 4. Unfortunately, in 2017, at cores 1 and 2, we saw a slight decrease following the second year, but it's still an increase from that first year and after initial outplanting. So each site had an increase in abundance. And this increase in abundance is nearly 130% increase in total colony abundance per site. And that ranged between 54 and 230% increase per site. And if we break that down to each individual count at each array, it was anywhere between 17 and 374% increase in colony abundance in that small area surrounding our outplants. And it's not in here, but what that also equates to is approximately 300,000 to 750,000 centimeters of increase in tissue. So while I didn't present the actual size and the tissue of those colonies, we're not only seeing an increase in abundance, but also they're not small colonies. We're not seeing little tips that are populating the site. We're seeing these big colonies that are continuing to grow And for instance, core 2 went from about 29,000 centimeters of tissue when we outplanted. In year 2, we were close to 1.5 million centimeters of tissue, living tissue at that site through propagation. Just to give you an example, what does 130% look like if you haven't been to an outplant site? The picture on the left is when we first outplanted a couple months following. The colonies are hard to see because they're so small, but they're underneath that yellow line. And it's approximately the same angle, but I drew the yellow line on that image on the right as well to show you where to look or where those outplants were. And what we see is an increase in growth in those outplants and then a propagation surrounding those outplants through fragmentation. Now you might be asking, well, there were wild colonies at the site. How can we really predict that this is actually coming from our outplants? What I want to show you here is the percent of colonies that have gone missing from our outplants. So in addition to counting all the fragments surrounding our outplants, we also did do the fate tracking of our colonies at those sites. And what it turns out is that after 2 years, they start fragmenting and they start becoming dislodged. I think it's because they get so big, they're just doing their natural thing. So we really see, as we're seeing an increase in colony abundance at that site, it really correlates with the increase in colonies going missing. If you remember back to that one of those first slides I showed you of this colony all of a sudden going missing, we're not necessarily seeing a one-to-one colony lost, colony gained in abundance. This colony more than likely fragmented into numerous colonies and has propagated the reef, maybe 10 colonies or so, unknown. We can't really track that. But we're seeing a lot of this influence from our outplants into that propagation. So I did a lot of harping at the beginning how I feel that this data is really valuable in comparison to what we have been collecting and talking about in terms of our success of restoration. And I wanted to put this figure up here to show you if we solely used our colony tracking data, we would be showing at these sites only a 40% maximum survival after 4 years, which I think many of you in the room would say, well, that's not a very successful program if that's the number that you're going to be portraying. However, I would argue that this method, that type of data collection is really not representative of what we're doing and the impacts that our restoration efforts are actually having. It can be used in conjunction with this increase in abundance, but really what we're trying to do is restore the sites. And so this data on the left is really showing that it's working at the site level and site restoration level. And lastly, I want to say that this isn't unique to outplants. We do a lot of monitoring of the wild colonies and wild populations here in Broward County and much of the Florida Reef Tract. And one of our methodologies is to look within this 3.5 meter radial plot. We have our divers go out and they start north and they swim around this plot going clockwise. And they look at the first 10 colonies that they find in this plot. And we do this 3 times a year. And for this particular plot, we did this from 2011 to 2016. And now what I want to keep you an eye on is where these dots move. And so they first started off the first 3 quadrants. But over time and triannually, these colonies and these dots are moving, which is what we're seeing in our outplants. And it's happening in our wild populations as well. So you see these dots that are just moving around. That's the colonies fragmenting, reattaching, new colonies forming, colonies being lost, colonies being gained, colonies splitting. So I just want to reiterate that it's really not unique to outplants, but our outplants are really behaving like our wild populations are. So to conclude, a majority of our sites really show that increase in abundance. And I think that our missing colonies are really adding to this increase in abundance at our outplant sites. And I want to point out that this isn't due to attachment failure, because most of our outplants that went missing are after years 1. Really, you can tell if your colonies are going to stay around within a few months after outplanting. It's really, I think you've seen now that it's similar to our wild populations. We're seeing they're behaving. They're doing what they're supposed to be doing. Miller et al. In 2016 did a reef study looking at the change in abundance at reefs in the Keys and saw there was a significant increase following outplanting of cervicornis in abundance compared to those that didn't have outplanting. So like Tom was saying at the beginning, any little bit we can do right now, it's really showing a positive impact so that we can help these reefs just hang on. This site level data collection is really important for documenting the success of an outplanting program, not just maybe cervicornis, but other fragile branching species. I think this type of data collection can really be modeled onto those species. The boulder corals, they don't get up and walk away, they may roll away, but this species is just really unique along with other fragile species. It's just really more informative, and I hope that this type of data collection can really help update our permitting and reporting regulations, and then also me and myself included and all the restoration practitioners here on how we talk about the success of our restoration programs and get away from that talking about individual survivorship, but more at the site level, what's going on. So there's still stuff to work on in this, future directions for documenting this abundance. We have a number of different partners who are going out now using a 5-meter grid pattern over their outplants. So what size is right? We use 7 meters, they're using 5. So to look at the difference between those methodologies and to really go forward with a method that's really understandable. Maybe they're moving even further. Do we need to capture that, or what do we need to be capturing? Maybe use photomosaics in conjunction with some of this data so we can also give a little bit better visuals for people to see. And then also going and delving into what's driving those site differences. If you notice, cores 1 and 2 really grew up fast and then they kind of crashed a little bit, where cores 3 and 4 had a slow incline. So what's really driving those differences? So there's a lot of people that helped. A number of people are here. Many of our nursery partners are here and helped with the development of some of these projects as well. So we'd like to thank all of them and then all of our funding sources as well. And that's it.